excuse me, possible products that you have would be, if you have a number between -1 and 0, you're going to have a positive and negative combined, so we can know that we're going to have one positive, one negative combined together. Also notice that the top two numbers, the -20 and -10, are greater, are not fractions, but 2 to the -4th and 3 to the -2nd are. 2 to the 4th is 1 over 2 to the 4th, 1 over 16. 3 to the -2nd is 1 over 3 to the 2nd, 1/9. So we probably have to combine one of the top two numbers with one of the bottom two. We have a negative and a positive, so that's going to fit with what we're doing. Eventually, we come up with the correct answer being choice B with the -10 and the 1/16. 2 to the -4. Number 2, which of the following integers are multiples of both 2 and 3? And again, we have terminology, integers, and multiples, which if you're not sure of some of the terms, go back to the other materials I'll show you at the end. If we identify the multiples of one of them, and like 2, they start with 2, well, any of the even ones could be possible. Then we just have to figure out which one divides by 3, or which ones divide by 3. So their correct answer is 12, 18, and 36. We could eliminate right away 9 and 21 just because they're odd. They divide by 3, but they're not divided by 2. So if we start with one number, we might be able to use the second one to determine that. Going down to number 4, which of the following could be the units digit of 57 to the nth power, where n is a positive integer? Indicate all such digits. If you look at 57 to the nth power and n is going to be some positive integer, we have 57 to the first power that we can calculate, and we can see what it is, 57. We can take 57 to the second power, see what it is, 57 to the third power, and so on. When we look at the digits at the end, if we take 57 to the second power, we have 7 times 7 as the units digit, and we're going to get 49. So that number is going to end in a 9, no matter what the rest of it is. So even if we don't calculate the whole thing, just looking at the last digit, we have 7 for the units digit of 57 to the first, 57 to the second is a 9. Then the next one will be 57 times that answer with the 9 at the end, so we're multiplying 7 times a 9, get 63, so 3 is going to be the last digit. If we multiply 57 again, we're multiplying 7 times a 3 to get 21, so we have 1 at the end. If we multiply by 7 again, we're going to have 7 times 1 to get 7. So we have this repeating pattern of going on. Even though we might not have punched them all out, we have, what do we say, 7, 9, 3, 1, then back to 7. So those are the only possible numbers we're going to have the units digit on those from that pattern. So choosing all the choices, and notice how many choices there were, 1, 3, 7, and 9. And again, we might not have to do all the work. If you do, that's fine, just takes more time. But you will get to it if you run through all of them. Another type of question is numeric entry questions. Questions of this type ask you to enter the answer as an integer or as a decimal in a single answer box, or to enter it as a fraction in 2 separate boxes, one for the numerator and one for the denominator. So you're actually typing the answers in a certain way. The tips for answering: make sure that you answer the question that is asked. Since there are no answer choices to guide you, read the question carefully and make sure that you provide the type of answer required. If you're asked to round your answer, make sure you round to the required degree of accuracy. Okay? Examine your answer to see if it's reasonable with respect to the information given. Quite a few directions here. Notice that in the bullets, telling you how to type your answer, and this would be very good to know exactly how to do this before you get to the test. So with some practice. Click in the answer box, and then type the cursor will appear, then type the number. To erase, use backspace. Negative sign, type a hyphen. For decimal point, a period. Remove negative sign, type the hyphen again, and it will disappear. To transfer this display button, or the transfer display button, the calculator will transfer the calculator display to the answer box. Equivalent forms of the correct answer, such as 2.5 and 2.50, are all correct. And enter the exact answer unless the question asks you to round your answer. Entering a fraction for negative sign, type a hyphen to remove a type again. A decimal point cannot be used in a fraction. The transfer display button on the calculator cannot be used for a fraction. Fractions do not need to be reduced, though you may need to reduce the fraction to fit in the boxes. So 4/8 you can reduce down to 1/2. So looking at the way the questions may be set up. One pen costs 25 cents and one marker costs 35 cents. At those prices, what is the total cost of 18 pens and 100 markers? Here you actually can punch out the information, or if it's mental, you might do it mentally. But here we end up with an answer of $39.50. They already give you the dollar sign, so you don't have to type it. Just type in 39.50. But if you type 39.5, it should be correct. And then for the fraction, rectangle R has length of 30 and width 10. Square S has length 5. The perimeter of S is what fraction of the perimeter of R? So if we calculate the perimeter of each, we get 20 and 80. 20 for the square and 80 for the rectangle. So we have a fraction of 20 over 80, which we can leave it at that, or we can reduce it down to 2 over 8 or 1 out of 4 or whatever. They should all be correct. That's the last one I wanted to show in this section. Well, I probably should mention on this number 4, it talks about give your answer to the nearest whole percent. And we have a decimal, or we have a percent of 33.33, so we want to round to the nearest whole percent, which is 33%. So again, pay attention to what they ask you for. And the last type of question is data interpretation sets. Data interpretation questions are grouped together and refer to the same table, graph, or other data representation or presentation. These questions ask you to interpret or analyze the given data. The types of questions may be multiple choice, both types of multiple choice, or numeric entry, so it's about anything here. Tips for answering. Scan the data presentation briefly to see what it's about, but don't spend time studying all the information in detail. You might not need all the information that's there. Bar graphs and circle graphs, as well as other graphical displays of data, are drawn to scale so you can read or estimate visually from such graphs. So they're trying to give you the correct information from the graphs. The questions are to be answered only on the basis of the data presented, everyday facts such as the number of days in the year, and your knowledge of mathematics. Do not make use of specialized information that you may recall from other sources. Only use the information that's there, or common knowledge. So here's a typical question, or a sample question. Just looking over quickly the information, we have the different stores, PQRST, we have the percent change from 6 to 7, and then from the year 7 to 8. The dollar amount of sales at store P was $800,000 for 2006. What was the dollar amount of sales at that store for 2008? We have a percent change. This is store P, so that's the only information we want to look at. We have a 10% change from 2006 to 2007. If we calculate that, because it's a 10% change, it'll be 110% of what it was before. So if we can multiply 110, or 1.10, 110% times the initial value of 800,000. Once we get that answer, we have a decrease of 10% from 2007 to 8. So we want to take 90%, decreasing by 10%, and multiply that. What's tempting is thinking that you have a 10% increase and then a 10% decrease, that you're going to end up with the same value. But you won't, because the second 10% is actually a greater amount based on a bigger value that you got for that at the end of that first year. At store T, the dollar amount of sales for 2007 was what percent of the dollar amount of sales for 2008? Give your answer to the nearest 1%. Looking back at the table, I think I can fit this all on here. If the dollar amount of sales for store, if A is the dollar amount of sales for store T for 2007, then 8% of that is 0.08A. So I'm looking at the very bottom screen of the explanation. That's the amount of increase from 2007 to 8. Thus, A minus the 0.08 would be 0.92A. That's kind of like we did in the previous problem with 10% off would be 90%. Therefore, the desired percent can be obtained by dividing by A by 0.92A, which equals the 1 divided by 0.92, or about 1.086 or 1.087. They ask us to round to the nearest 0.1%, the nearest tenth of a percent. So at the very bottom of the screen, they give that to us as 108.7%. Number 3, just want to point out that the question asks you to indicate all of the statements that are true. Be careful, make sure you analyze each one of those. So on the left-hand side of the screen, we had the 5 different types of questions that are asked. Okay, and like I said, can't really go through a lot of the content. Just way too much to do that, but at least you have an idea what the questions would look like. So becoming familiar with that would be very, very good. And even becoming familiar with the format of the questions, the type of questions, how to answer the questions. So now, if you didn't realize what the test would be like, you thought it would all be multiple choice, at least now you know that's not what is expected. In the comparison, you have the entry ones and so on. So at least you have an idea of that if you haven't seen anything on this before. The calculator that's included with the quantitative reasoning part of the test is this one, and I think I think this is the one that you have to use for the test. You might have to read that, make sure, but I believe that's the one you're limited to. So become familiar with how to use that fairly efficiently. Most of the time it's the same thing as what you do ordinarily, but there may be some functions on there that you want to know how to use more exactly. If you've been using graphing calculators for a while, then things might be typed in a different order. You know, in graphing calculator we type the square root key and then the number. Here we might reverse that. If you might want to read about that to make sure. They give you some tips, some guidelines. What I would probably just point out in here, that, and they say some things more than just this, but sometimes it's really wise to use a calculator. Sometimes it's probably faster if you can do it mentally. If it's something really small, why waste the time? However, if you're unsure of yourself and you're trying to keep your mind on the problem, it might be best to punch it out. Don't try to clutter your mind and hold numbers in there when you can punch it out more quickly, actually. And then they give some explanation on how some of these can be done. The number 4, just because this comes up in my classes, be careful of how you use your parentheses to calculate values. Here they have negative 15, the whole thing's being cubed. So they put the 15 plus or minus to get the negative sign, and then they actually multiply 3 times by each other because they don't have the exponent key on there. But they take 15 with the plus minus key. I would probably also think of just taking 15 times 15 times 15 and knowing that I have 3 negative signs, so you make it negative. You know, not have to punch all the pluses and minuses. These last 2 places probably can give you better ideas on the type of mathematics and the terminology needed. I didn't want to do that. Okay, notice this is 102 pages long. Okay, that's a lot of information. You might not need all that information. Some things you may know very well. However, if you need to familiarize yourself with the information, they have it broken down in the table of contents with arithmetic, algebra, geometry, data analysis. Looking under arithmetic, has information on integers, fractions, exponents, and so on. If you have some area that you're not sure of, go ahead and read about it. You can look, you can get to things you need to do rather than reading the whole thing, or scan through and see the things that you know and that you don't know. Algebra, same type of thing. How do you solve linear equations, quadratic equations, and so on? What are functions? Geometry, data analysis, and here's what the explanations look like. Remember, the first part was integers. Here they describe integers. What are they all about? Greatest common divisor, or greatest common factor. Just scrolling through different things. A prime number. Fractions. How to handle fractions. What are they? How do we handle those? And so on. Sometimes, when we find this out, even from our math majors, sometimes we find out that they're pretty good at the algebraic stuff because they've been doing it for a long time or continuously, but they have forgotten quite a bit of geometry. Oh, there's also some nice graphical stuff here if you need to review graphs and how they behave. But sometimes, like I said, even our math majors, when we review them on algebraic topics, I want to show this before I get to geometry. When we review some of the mathematical topics, they struggle more with geometry, mainly because they took it back in freshman, sophomore, junior year, whatever, and haven't been around it. And even though we work with some geometry in our higher math and our calculus and everything, there's some properties that they had forgotten. So that's an area that you may want to take some time on. Here's what I wanted to back up to before I get to geometry. They had the explanation for the integers and all that stuff and the numerical stuff. Now the algebra. And at each section, at the end of this algebra section, for example, they have some questions for you. So questions outside of the other ones that you saw and outside of the practice test. And I believe this will be something similar that you're going to see in the booklets. And then they have the answers to those questions. So some nice practice problems before you actually get in and try to do some of the practice tests. Especially on things that you may be struggling with or need more review on. It wouldn't hurt to become very good at things that you think you know already, though. So even doing some problems that you think you know how to do already would be good to make sure you know. But geometry, this is one that throws people off. Like I said, even like our math majors, they forget sometimes some of the properties. Some basic terminology again. We need to know different types of, the terms for different types of parts of our geometry. Here we have acute, obtuse angles, parallel lines. Some of the properties with parallel lines and properties of the angles of those parallel lines. Polygons, again, more terminology. This is probably one of the things that throws people off more. There's so much terminology associated with geometry that we really need to do well on that part of the test or in the class. Isosceles triangle, hypotenuse, right triangle, a lot of terminology. Parallelograms, trapezoids, circle properties. There's a lot of information in there on all the topics. But geometry, like I said, that's one that probably needs to be reviewed some, just because you've probably been away from it for a while. And then at the end, geometry exercises, just like you saw in algebra. And the answers. And then data analysis could be, again, there's terminology involved, but it could be something that maybe you're more familiar with just because things you've done in other classes or statistics, if you took it from us, that you might have done some work in there that you're familiar with. But if not, we have some other reminders on what you may have done or may not have done in the past. Different types of graphs, how to read the graphs. Circle graph, how to read it. Histograms, if you remember that, if you took stats. Scatter plot, there's a lot of information on there. And then at the end we have our practice problems again. And I believe